This is Unit 6.4, and it's about triangle proportionality theorem. And what does the triangle proportionality theorem states? It says that if a line is parallel to one side of the triangle and intersects with the other two sides, then it divides the sides into segments that are proportional length. In other words, if we look at this example, I've got DE is parallel to AC. Segment DE and segment AC are parallel. Then on the side, these two corresponding segments are parallel. In other words, then BD over DA should equal BE over EC. And the converse of that is that if BD and over DA equals BE over EC, in other words, if these two segments are proportional, then these two segments are parallel. Okay, if the sides are proportional, then the two segments are parallel. That's the converse. So let's see how we're using it. In the example number 1, on the side I have 12 and 14 here, and over here I have 15 on the other side of the triangle. I know these two lines are parallel. What does x has to be in order for the two sides to be proportional? So you simply set up this proportionality here. 14 over 12 should equal x over 15. Now, let me use a different color. If you set it up in the reverse way, that's fine too, as long as you're consistent. Okay, so if you solve that equation, you cross multiply, and x should come out to be 17.5. Number 2 is the same, so finish number 2 on your own. And let's look at number 3. Number 3, I have the whole side on this side to here. From here to here is 55. So and this is 45. So then I know this portion is 10. So again, if these two segments are parallel, I just need to set up my proportionality here. But you do have to be careful about how to identify, how do I calculate this length of 10 there. And if you cross multiply, become 45x equals 365. So x is 8. That's your final answer there. Okay. Number 5 is the same thing. It's just a little bit more algebra. So again, they have to be proportional. 30 over x plus 7 equals 25 over 15. Do use your brackets or parentheses liberally so that you know that your value is protected. Because sometimes I've seen you guys in class just write things. So for example, you would write something like this: 25 times x plus 7. Now in your mind, you know x plus 7 is together, but this is this does not equal to each other, because this, if I have to calculate this, is 25x plus 7, right? It's rather than 25x plus 25 times 7, which is what am I trying to achieve there. So do use your parentheses very liberally to help protect yourself. If you do your distributive property and you make the calculation, your x should come out to be 11. Okay, so I did demonstrated the odd numbers. Pause the video and finish the even number practices. 7, 8, 9 is to determine whether, so it's given you the sides of a triangle, but it's asking you to determine if the two segments inside the segment inside is parallel to one of the sides or not. So in this case, we use the converse of the triangle proportionality theorem. So I'm going to jump straight into number 9 to demonstrate that. Here I've got a triangle. 30 is here. Let's see, need my pen here. 30 is here, 37.5 is here, 24 is there, and I don't know this side, but that I can use 54 minus 24, so I should have 30 there, right? So then if I set up the proportionality, and I should see if 30 over 37.5, does it equal 24 over 30? And then you start simplifying them. You will find out, or use your calculator, you'll find out that they arrive at the same answer. Therefore, it checks out. So yes, that is, they do parallel with each other. Okay, let's look at number 8. So I have 15 over 4 on one side. I have 18 over 5 on the other side. You can simplify it, or you can use your calculator, and you'll find out that they don't equal each other, and therefore these two lines are not parallel. So I should have marked JL is parallel to MN in 9, but not in 8. Okay. So that's the triangle proportionality theorem. It's fairly intuitive. Now, if we expand that a little bit, if we don't look at triangles, we can actually look at other diagrams like the one that's in front of us. And this gives us proportional parts and parallel lines. This is really just putting the triangle proportionality theorem into practice. And what this says is that it says if 3 or more parallels intersects 2 transversals, then they cut off the transversals proportionally. Notice that they all have to parallel to each other, and the proportionality is here. So if AB is parallel to CD, parallel to EF, and these are all lines, right? Then AC over CE should equal BD over DF. And I'm going to move this up a little. Let's look at number 10. I have 3 parallel lines here, and I'm asked to find x. So I have to use the proportionality. So 45 over 18 should be the same as 52 over x, and x comes out to be 20.8, I believe. Okay. Number 12, same thing. I have x here, 27 there, and these 3 lines are parallel. I need to know here, and that's simply 32 minus 18. 32 minus 18, that would give me 14 here. So 14 is here. So 14 over 18 should equal x over 27. And if you solve for x, x comes out to be 21. All right, so everything else is almost exactly the same. This part is not hard at all, but you do need to understand what parallel lines do to the transversals, which will help you set up the proportionalities. So finish the rest of the practice, and I'll see you in class. Thank you.